Hi, my name is Muzni from Commuter Facilities and Systems Management Division. Today I'll be talking about the design for operations and maintenance and why it is important to consider these operations and maintenance considerations at the design and planning phase. Content of today's presentation: overview, generic requirements, design and detailing, interfaces and materials. Okay, the typical stages of an infrastructure will comprises of planning, design, thereafter the implementation, construction phase, and the maintenance stage. So starting with the planning and design phase, it is of utmost importance land ownership and regularization is done at this point so that we can avoid any downstream maintenance challenges. Next few slides I'll be covering on the operations and the construction aspects of the commuter infrastructures. Okay, this slide talks about the concept of integrating design for operations and maintenance. The importance here is when we design for operations and maintenance right at the planning and the design phase, we can minimize the downstream maintenance challenges, and it helps us to have a cost-effective maintenance regime, which is pretty important considering having a large infrastructure maintenance database. General requirements. For LTA to consider to maintain, all commuter facilities must meet the following criteria. Firstly, it must serve transport node. The assessment whether it serves transport node will be done by LTA. Secondly, it must be within the public street, state land. Thirdly, 24/7 accessible to public, and also should meet LTA standards and requirements. Any encroachment into private land must be highlighted to LTA and regularized right at the early stages. Land alienated to other stat board land is a private land under the Street Works Act. So all design and constructions shall comply with the LTA standards, the MNW specs, the civil design criteria, architectural design criteria, the other codes of practices for works on public streets, BCS code on accessibility, as you can read on the slide. The first item for today would be the design and detailing. For the ease of replacement of structural parts, the foundation of the shelter shall be independent from any box drain structures on the adjacent side. This independency is important. Why? Because whenever there is a linkway replacement works in the future, or PUB drain structure widening, if there is such an upgrading works or a replacement works, we will not need to affect each other's structure. Affecting each other's structure would result in a bigger scope of work, more cost implications, etc. So in order to have a very clear ownership and maintenance responsibility right from the beginning, we have independent structures. Of course, this is the ideal scenario that what we want. But we do understand there can be site constraints. Sometimes space to have such independent structures is very limited. So for cases like that, we have designs that PUB and LTA has agreed upon, where we can accommodate linkways mounted on drains. Also linkways constructed right next to the drains with agreement between PUB and LTA. This also depends on the size of the drain. So there are approaches that has been practiced, so the submissions can be reviewed accordingly. So second item is the for ease of replacement of structural parts. Commuter infrastructures shall be designed as an independent structure and not structurally connected to any adjacent building. Talking about this, I mean, this is not an uncommon detail, and it can be found across at many other developments as well. As you can see, the shelter here is a pickup drop-off point that is to be designed and constructed and handed over to LTA to maintain. So this one is to be handed over for LTA to maintain. However, the adjacent building, as you can see, is owned and maintained by a different entity. So what happens here is that how do we establish the maintenance and ownership? because once you structurally connect to the adjacent building, there is always loading, structural loading going back to the building, which will complicate downstream, have downstream maintenance challenges. Down the years, when we are trying to do a replacement work or an upgrading work, if we need to repair or replace a linkway, we will have to affect the exterior of the building. The building structure will be affected. So in terms of identifying the responsibility, who's going to undertake the works, the such scope of works, the cost of works can lead to disputes and disagreements, So it's always neater to have simple and neater to have independent structures. That is, if it is to be handed over to LTA, its own structure and own columns, and not structurally connected to the adjacent building, right? Okay, item 3 is cladded roofs and false ceilings. They are not recommended. Why? Because as we do inspection, it covers up the interior of the structural members. As you know, the steel tends to corrode. So once the cladding conceals this, and we are unable to easily look for such problems. So we don't recommend, and we want majority of the linkways to have no claddings and no ceilings. However, at special locations where needed, we can consider such arrangements, provided there are inspection points at intervals, so that we can access to look for any faults or any to monitor the health of the structure, to look for corrosion, and also if the cladding and false ceilings are easily removable and if there's a mechanism to easily remove and replace, so we can consider for special locations. Okay, going to the next item is for ease of replacements, we prefer the design of the shelter to be modularized. So current design is 3 meter panels. At the same time, the steel structures should be designed and constructed in a bolt and nut system. So this way you can easily remove, easily replace, and it makes maintenance much easier. So this slide mentions we do not recommend welded connections, welded extensions on site wells. Creating additional wells, there's always a chance that it can shear off if not done properly, should there be an external force knocking onto the structural column. Of course, as per today's practice, butt welds are commonly used technique in the industry, and should there be any site constraints resulting in changes of dimensions. So whenever site constraints, unforeseen situations, they do practice wells done accordingly and certified by the relevant certification authority. The intent here is to minimize on-site wells as much as possible. So that because these are steel structures, these steel structures can be prefabricated and easily transported. So why we need to create additional wells for extension? So that's the whole intent, that's the whole purpose. So during design phase, it is important to for the consultant to go down to the site, study the site, and look for what's the alignments, what's the dimensions needed, so that we can minimize such on-site wells, on-site extensions as much as possible. The roof of the shelter shall be designed with sufficient gradient for an effective runoff. Today, the fall of the shelter shall be a minimum of 3 degrees. We recommend this. Why? Because this is for self-cleaning purposes. For cover linkway, as you can see the red arrows where I have shown, this is how the gradient of the roof should be, and how the water flows out onto the roadside drop inlet chambers. The considerations here is that we want to avoid a situation where pedestrians end up walking on the runoff as the water flows across the footpath. So we want the water to drain off, immediately go to the closest roadside drains, roadside drop inlet chambers. However, as for the bus shelter, the gradient is gradient of the roof is towards the back of the shelter. The reason why we're adopting this is we do not want water to splash on to the commuters during boarding and alighting activity. So it's natural, the water to flow back, and also it flows down, and then it flows onto the roadside drop inlet chambers. So there's two different considerations for cover linkway versus the bus shelter. Okay, for footpath and any granulatic platforms below the cover linkway and below the bus shelter. So it is important that they are graded properly. This grading is essential. I mean, you can look back to the SDRE. This grading is essential. Why? Because water will be properly discharged onto the roadside drop inlet chambers, and there shall be no stagnation. And so it is important when we are designing a bus shelter and a cover linkway, the flow grading is also taken into account. Yeah, so this is adding on to the previous slide. The footpath shall be higher. So if you look at the SDRE details, footpath is at a higher level, and then the turf, and then the road is at a lower level. This profile is important. Why? Because when there's surface runoff on the footpath, it's supposed to flow onto the road. The roadside drop inlet chamber is supposed to capture this and then flow into the public drains. So naturally, the footpath should be designed at a slightly higher level in order to achieve this gradient. This way, we can avoid water ponding. So for footpath extensions, let's say there's a cover linkway coming and then you need to extend it. And it is important when we do an extension, double bar of adequate size and adequate spacing is installed so that we can avoid differential settlement between the existing concrete and the new concrete. Okay, for existing gratings on a slope, the concern is slipping concerns, of course. So it is important that we apply anti-slip coating that has a adequate slip resistance to avoid any slip and fall, especially on gratings, on existing gratings on ramps. However, for new locations and new locations where footpath has to be on a slope, please design, please make sure there are no gratings on the footpath ramp. It is important because we should be avoiding gratings on footpath because it will lead to slipping in the future. However, should there be a need for a grating as per PUB's requirements on the footpath ramp, we can consider the concrete grating as per the latest SDRE. To prevent any excessive surface runoff, whenever there is commuter facilities, let's say there's a footpath or a bus shelter or a cover linkway, sometimes the adjacent land can be at a higher ground. So what happens here is that whenever there is rainfall, water from the adjacent ground flows naturally onto the footpath because there is no adequate collection points or drainage within the adjacent land. So when there is no drains designed within the adjacent land, water flows onto the public street. When the water flows into the public street walkways, it's going to create a lot of inconvenience with a lot of feedbacks, people using the commuter infrastructure. When there's a situation where a commuter infrastructure is next to an adjacent land, please ensure there is a cutoff drain built within the adjacent land, and the cutoff drain should be also handed over and maintained by the adjacent landowner. Why we say the adjacent landowner, there must be a question to many people. PUB's requirements are that any landowner or building owner must make sure water that's originating from their land is properly discharged into the public drains and not discharged onto the public streets. Examples of the issue that I was talking just before. So this is so when the commuters are walking along the footpath or using the bus shelter, there's going to be a pool of water flowing across there on the walkway. So it's natural and normal for people to expect their feet to be dry, provided, I mean, their head is dry because of the shelter, but now there is a a pool of water gushing through and their feet is wet. So we do have a lot of feedbacks of such cases, and we should try to avoid such situations as much as possible. Okay, for standardization, steel members of columns such as the rectangular hollow sections and the square hollow sections are preferred. This is to have a readily stock available so that we can easily carry out our repair and replacement when required. Okay, all pre-designed holes for services, wirings and connections on structural members, it must be treated for corrosion. If not utilized, they shall be sealed. Moving on to the next part of the presentation will be interfaces. So interfaces you can see between whenever the cover linkway meets a low cover linkway meets a high cover linkway, or a cover linkway meeting a bus shelter. So they were designed and built at two different times. So sometimes there's a need for a transition or an interface so that this flashing or the design should prevent water splashing onto the commuters. So we had to ensure proper interfacing, proper flashing, channels are provided so that water does not fall onto the commuters, but it falls away from the commuters. It shall be properly installed with sealant, adequate sealant, so that there is no water ingress. And also gutters are not allowed due to potential chokeage and mosquito breeding. The example of water leakage. So if the sealant works are not done properly, water will tend to seep through and will be falling on the public, while they're walking, while they're using the cover linkway. Okay, materials is the next item that I'll be talking about. Antistick coating is a paint which prevents any stick-ons or any advertisement. We recommend this to be painted on cover linkway columns, bus shelter columns. This is to prevent any illegal advertisements or sticker residues. And also, it is unsightly to have a lot of advertisement pasted along the public infrastructures. For standardization, we have several bus shelters and cover linkways with roofing materials which is constructed using aluminium honeycomb composite panel. This is light, easily found in the market, and easy to replace. Also, composite material advantage is that it can function as a lightning conductor, and therefore a separate lightning conductor strip is not required. And the material of the roof shall be able to withstand exposure to external weathering. And like I said, it should be readily available in the local market with appropriate warranty, and then the full details should be provided to LTA. That's the end of the presentation. Thank you for listening.